All right, so if you guys like access to the Etherpad, this is the link right here at the top. Emulation going beyond local QEMU. So my name is Jonathan Race. I come from the United States, from Georgia. I work at the Georgia Cyber Center. So we ourselves aren't a public cloud provider. We leverage OpenStack on the private side to provide an environment that's flexible and scalable for research, testing, evaluation, kind of trying to target on critical infrastructure, OT, IoT type systems. So that's where kind of this work came from. So there's various links in here that will kind of give you a background on why we pursued this initial work and kind of paint out a little bit of what we're looking for. So whether anybody has actually used what was implemented during yoga or not, valuable feedback is still great because I am in no means an expert when it comes to various aspects of this, but I am a really good integrator of technologies and can get things to work how I need them to. But the overall point of this was to bring more scalable capabilities into the cloud environment. So rather than, a lot of times nowadays people use QEMU, they use libvirt, we use it, obviously it's used heavily with an OpenStack when we're talking about software development, we're talking about systems development. On the local side, yeah, it's great to be able to leverage QEMU to do a lot of these things. However, from our aspect, how great would it be to have that capability within the cloud? So being able to leverage cloud native orchestration or automated through automation through CI/CD deployments and developments to be able to do that testing without necessarily having to have that hardware to do that. Now where I'm located right now with the cyber range there, we run all on x86 64 architecture. We have the ability and plans to implement actual physical architecture for some of the emulated stuff in here. However, once again, it's going back to the aspect of, well, now anybody, right, whether they're operating maybe Cola, Ansible, or any other flavor of OpenStack, as long as they're pulling from the core code, with the current release of Yoga, this is fully functional and capable. So at my house, I run my own little local Cola Ansible deployment, and I can do the same exact thing with emulation as I can at work. So some of the current efforts that I was able to make during the yoga cycle, really great dev team on the Nova side for bearing with me and helping me. As I kind of get snapped in, I'm not a full-time developer. I'm not paid specifically to develop on OpenStack, but because that's the product that we leverage, it behooves me and our team to kind of contribute to ensure that some of the capabilities are there that we're looking for as we enjoy the product and see the future of it. So some of the resources are there as far as to some of our local documentation that kind of state the purpose of of this feature set, as well as the work that we did during yoga. So we come to find out, being brand new to high-level open source contribution, was able to get snapped in and get take advantage of a kind of existing blueprint, and had to draft up a technical specification for this that talks about some of the features, as well as kind of provide the aspects of how to actually leverage this. So with it, the initial support that we have, obviously x86 64 is native, but also providing for this capability can be leveraged on both that side, or maybe if you're running Arch hardware or ARM hardware, it can be leveraged that same way. So these are the main architectures that are currently supported and tested. So PowerPC, IBM's S390X, and then Arch 64. MIPS, the code is there, but I'm working through some efforts to get a patch put in on that actual core source code, so you don't have to manually patch it to get that functioning. But the core code is there and functional to allow for this. Now some of the caveats with this, right? This isn't meant for production use, right? Because it is using QEMU emulation. So in this case, right, it would fall under the category of kind of non-virtual use case. So from the security aspect, keeping that in mind, right? But when it comes to trying to, let's say, put together critical infrastructure type systems, or taking some of those systems that in today's age are mainly physical systems because of the type of operating system or the type of firmware they leverage, looking at trying to bring that to the forefront to be able to, once again, bring that scalability and that orchestration and automation that the cloud provides. So getting some of your guys' input, so having all that in mind, and seeing all that, by all means feel free to add here. I added some initial items. I was able to attend the PTG for Nova and get some of their great feedback, as well as right now this effort for this feature set overall, I'm the primary lead from my organization to do the work, because I tend to work a little bit quicker. But it's getting feedback from you guys as well as your expertise, whatever it may be in regards to virtualization, leveraging QEMU, working with some of those alternate architectures that aren't on the main front, and how that would apply. So obviously, first thing there is letting everybody know that is there and that it's functional, and I can show you guys what it looks like if that's something that you would like to see. But then also looking at kind of where we're looking at going. So one of the things that we weren't able to do this last cycle was implement support for RISC-V architecture. RISC-V 6.4 is the forefront, but looking at support for RISC-V 32. Some of that was a couple of things. There was some extra source code that would need to be looked at, evaluated. That was kind of giving us some hiccups, but then also running into support in regards to how that actually boots within OpenStack itself. So from the hypervisor perspective, right, it has some support for when it does QEMU booting, so such as like U-boot or SBIOS. There's some inherent capabilities there, and there were some package installs that I had to do on our platform to kind of support it. And then as you see here for the RISC-V support, there is some initial work that was being worked on. I want to say last time it looks like it touched. I didn't look at the most current, if there was a current branch or anything associated. But in the past year to 2 years, there was some work being done on trying to generate some OVVMF file descriptors to be able to support this, which in that case, right, that means it would be a lot more easier to integrate it on the OpenStack side from the source code of Nova. And because it is an experimental feature, right, it doesn't have the full scope and capabilities of maybe, of your standard instance. So there are some limitations in regards to being able to evacuate your compute nodes of these hosts, or in case of a failover that was needed, or being able to attach volumes, or some of those more intricate capabilities, simply because some of these architectures aren't necessarily built to support IDE, or they're very specific on how they have to be configured. So another aspect from that RISC-V is having that greater parity and making sure, like, hey, these are the features, obviously the current feature sets of, hey, this is what's included for support for instances, but being able to show that from the emulation perspective. I understand there is a SIG for multi-architecture, and that's more on the hardware level of support, which is great, and that's where a lot of the work was great for me, because I didn't have to necessarily create everything from scratch. Because of the work that they're doing to support the physical architecture, it makes it a little bit easier for the emulation, because we can leverage a lot of the same code or put simple checks into, hey, if it meets this criteria, then go ahead and leverage this already existing physical architecture code to build out that system accurately. Other things that were brought up from the PTG, obviously, it'll take more work on my part and research, and by all means, this is open for anybody to kind of collaborate with if they have a desire to see this or leverage this. But one of the things that was brought up was being able to maybe do some evaluation of trusted signers on those OOVMF file descriptors to kind of bring some security and integrity to. One of the things that I brought up was being able to use custom firmware, right? Because when it comes to some of these multi-architectures, using the base stuff is great, but a lot of times you're creating custom firmware for that particular OS to be able to boot from. So it's wanting to look at the perspective of how can we leverage that within OpenStack. I know that with AWS and AMI images, right, they have the kernel image and the RAM disk, so maybe able to leverage something like that, but that's something that we'll be looking at during the Z cycle, not necessarily to implement, just because I don't necessarily have the cycles dedicated to that, but being able to look at and detail the work. So coming the beginning of next year, for the cycle after Z, we can kind of head directly into doing some preliminary testing prior to that, and then head directly into submitting whatever specs may be needed or blueprints that may be needed in code. So it'd be looking at that perspective of those are the main discussion points that I kind of had going in. Like I said, by no means am I an expert or am I deep within OpenStack as far as a solid contributor, but I contributed this last time, and I mean to contribute and get my team to contribute more code, so that way we can kind of get ourselves on there to ensure from our perspective that some of the capabilities that we see for future that would be needed can be met. So with that, knowing that this is supposed to kind of be a back and forth, I don't know if anybody right now has any kind of input. Maybe they've leveraged it, they've tested it a little bit, or anything that they can see based off of this, or even any questions in general related to it.
So it's obvious that the virtual machines that you're running in TCG mode are not for production use.
Right.
But from an operating system vendor's point of view, I would imagine lots of people are not enabling TCG in their QEMU, so because they don't want to have to support it. And like, you may not see the VMs as being production, but the operating system that you're getting from the vendor is production, right? Right.
Yeah,
so
we're not building any custom image. Yeah, we're not spinning any custom images, right? So what I have spun up right now in one of our environments, right? We're using, I think, Ciros for Arch, and then we're using Ubuntu's cloud production images for S390X and PowerPC.
What about the actual host operating system?
So the host operating system, as far as what we're providing, what we've tested under, what we host on, is we use Ubuntu rather than CentOS or RHEL. Just because one of the benefits, right, of using OpenStack and kind of following the route of open source is it brings down a lot of the cost depending on the route you go, but then it means you have the onus for the support of that cloud environment. Mm-hmm. So for us, because we have the technical expertise to kind of put all the pieces together ourselves, right, we kind of do our own deployment framework. But yeah, we use Ubuntu as our base OS, as our bare metal OS, and then we deploy on top of that. So as far as when it comes to those other cases, right, the initial point was to make this generally available, to see, to get people to kind of see it and see if they want to experiment with it or provide it, right? So like I said, we're not a public cloud vendor, and the only reason for that is because we don't necessarily have the team to support it, nor do we want to pursue that route, because we focus specifically on testing, evaluation, research, training, and education. So it takes out all the complexities of, well, now we have to meet these specific data protection requirements, or these specific requirements. But it makes it really nice because from a customer's perspective, we can really do whatever they want within the environment. So some of the stuff that we do is, like mock power plant or mock water plant type scenarios, right? So from a customer's perspective, if they don't want to initially invest in buying a whole bunch of hardware to do a mock-up, well, now we can do it all virtually within the cloud as an initial mock-up. So from their perspective, they can gain a little, that initial confidence before they make an even larger investment to go the next step, which is where we saw from the perspective of critical infrastructure, that's something that's important to anybody, but it's very limited as far as doing testing and evaluation on that without working specifically with vendors and working within their parameters or their proprietary systems that only they have access to. So it was looking at from the perspective of how can we bring more of that to the forefront of developers, making it so more accessible versus less accessible, or you have to have the hardware to support that. But yeah, definitely taking I think expanding it to look at the perspective of host OS.
Yeah, rel
Yeah.
won't ship TCG.
Right.
And doesn't support nested virtualization, which I know is a different thing, but it's not part of the virt stack. But it's a fun idea to be able to spin up little ARM boxes and throw your routing the software at them, or
Yeah, well, and that's the whole thing, right? Because for us, so we deploy, we use GitLab as our code for our uniqueness stuff, but we use everything through CI. So for we call ourselves a cyber range, but that's because we're not providing a traditional cloud environment. We're providing complete network environments of whatever you want to mock up. So from us, we deploy everything through CI/CD. So whether we want to deploy one or whether we want to deploy 100 and have it execute that code, right? You can integrate with with any other automation that you have. It's just a matter of, well, now it's there, so now it's saying, okay, well, rather than me trying to do this all locally using containers or locally on my system, on my system that's set up to do this, well, let's try to expand that a little bit, right? It's not meant to be the end-all solution as of yet, right? Because that all depends on how some of these other projects all go and how some of that capability is there, but definitely a starter to kind of provide more access. Any other questions or comments or things to note? So this Etherpad, like I said, it is open, so by all means feel free to contribute as you as you may identify anything, right? I'll be here throughout the entire summit, and by all means I'd love to talk with or pick your guys' brains, or you can pick my brain on some of the stuff that we do, to kind of show what it kind of looks like from that perspective, right? So when we're looking at the images within OpenStack, what it essentially provides you is these two extra fields that you can take advantage of. Hardware machine type is already existing, but the additional field that was added was hardware emulation architecture. So providing that particular architecture, right, whether it be PowerPC or Arch or S390X, that's just a tag that you put on the image within Glance. And then when you go to spin up that particular image, it will spin up leveraging, following the path route, so making sure that you have everything enabled, right? So for S390X in particular, you have to have serial console enabled in your environment to get that to work, right? So in our environment, right, we support Spice, HTML, but then we also have serial spun up as well, just so we can support both types of technologies. And then from the perspective of what that actually looks like, right, from the perspective of seeing it within the environment, well, now you have your instances to where, we have our PowerPC and what that looks like from doing a lscpu command, looking at it from the perspective of our S390X, and then from the perspective of our Arch64. And like I said, these aren't custom images, right? So this one's put up a certain way. These are pulled directly from Ubuntu and uploaded directly, applying those glance image metadata values at upload.
Yeah. So you used emulation Arch instead of hardware Arch.
Yep.
So that you can, I assume, emit slightly different domains for libvirt?
Yeah, right. Yeah. So when it comes to libvirt, right, there's only certain support, right? So I think with S390X, right, one of the biggest things was IDE support for some of those architectures. So it's making sure, as I said, it's great that there's multi-architecture support from the hardware level. So it was really doing kind of a deep dive analysis to see, okay, well, where are the different checks made for the different features that are needed or that can be supported. That way, when it comes to you doing your local command of QEMU, whatever binary, and then the long string of how you're going to build out that system, making sure that it follows those same standards, right? But there's some difficulty because you have the QEMU project and then you have the libvirt project who aren't 100% the same. So it's looking at, okay, well, this one supports it, this one doesn't. So from not just the OpenStack perspective, there's some work that needs to be done from looking at, well, what needs to be pushed for maybe on the libvirt source code perspective or the QEMU source code perspective to get a little bit better parity. And like I said, for the time being, as this stays in here, the goal will be, this is always going to be experimental, right? Until maybe, who knows, 5-10 years from now, maybe there is that parity, who knows, to provide the security that would be needed that you see in production use. But I don't think, who knows?
TCG.
Right, yeah, right. But definitely from the experimental testing evaluation perspective, right, that was the real goal with this, is getting that there, so it can be at least a test bed and a starter conversation for how companies can maybe leverage this, right, because it takes out that whole cost factor, at least the large cost factor of having to make, sink a bunch of money, where you can actually, build something out initially to see what that would look like and maybe how it will interact with each other.
So do you tag the images as well?
So you can go beyond that, right? But right now, so it's however, I kind of left that up to the individuals that are going to implement this, right? So from the operator perspective, we only depend on that metadata tag on the glance image, or the metadata, that hardware emulation.
Oh yeah, okay.
Field that we had implemented. There was some initial look at like reuse of certain things by the company who was looking at implementing this prior to. But one of the problems with hardware reuse, especially for this type of feature, is I wanted to stay away from changing a lot of core code because there's no reason to do that if I can just add a simple check instead of rewriting a whole section.
Yeah.
So it does it just goes back to a primary function. It just does a bunch of checks to see, okay, well, is the emulation field defined? Okay, it is. Go ahead and follow this path instead of the default one. Any other questions or comments? So like I said, the big thing for this is we're not using. I won't be doing any development during the Z cycle for this, simply because we have other engagements, because we're not dedicated to OpenStack development. But the goal is kind of using the PTG and then this, and then whatever other collaboration conversations I have after this until the end of Z is going to be really gathering the more fuller requirements and doing some evaluations to see, how we can make the utilization of this easier or meet some of the criteria. So, looking at it from that perspective, right, knowing that we're using tiny code generator, seeing how we can, is there potentials for making this more widely accessible if you're not providing a private cloud type environment, right? So how could this be more open to public cloud environments that are being hosted or around the world, or that your companies themselves are hosting? So that way, from a customer's perspective, right, again, that greater share, they can, the whole goal I see this is it provides a greater capabilities because it's built by the people that need it and want to use it, so you can provide a bigger capability set.
Actually, maybe you can take the last minutes to discuss with the room if they see use cases for that. I mean, I just wanted to, because I understand this is experimental and we discussed that a couple of times when we reviewed that. But yeah, I mean, how could that be useful for the audience here if they start wanting to use that? In which kind of business cases they will see the usage? You are talking about public clouds. Do we see any other usage useful for some I don't know, for some people running? Do you see? I mean, you or maybe someone else do you see any kind of use cases for that?
So, yeah, if anybody else has an answer. So I think, right, so from our perspective, it's always one of those things. It's tough when it comes to features like this, as far as, what use cases do you see? And from my team's perspective and where we kind of reside, we do see various use cases. I think the initial thing is people knowing that it's out there and getting more use by people. right, to not just, okay, well, we have these 5 use cases, but as more people try to leverage those use cases, or it's more widely known that they can, I think that's where more traction may come on this, right? Because the biggest use cases that we see really is that initial phase when it comes to doing the testing, evaluation, and research, when it comes to OT, specifically OT and critical infrastructure environments, where you have these architectures, where you either have to put the hardware together yourself, or you have to work with some other company to be provided a physical system to where now we take that as maybe that becomes step 2 or 3, and this becomes the initial step of let's go that route. So where we're at, right, we have some initiatives that we're pursuing with U.S. vendors for specific research, within the medical device field and within the critical infrastructure field, to, I would say, to probably flesh out some more solid use cases. So when it comes to thinking about emulation within the cloud, being able to present that and show it, so from a user's perspective, it makes a little bit more sense than going down in the weeds and what this entails with implementing.
Yeah, I can tell a bit about the use case I see, but it's pretty moonshots. You have to really understand that. So from our perspective, what I'm trying to have a look at is, I know nothing about this, you need to be aware of that, right? Is that we are in evaluation of, so the things that are on top of our infrastructure, on top of our clouds, we're running managed services, and we have regularly, let's say, demand, request to evaluate the power consumption of those managed services on top of our infrastructure. And so we've been told, and this is why this is probably the moonshot story, that if we were to change software to a different architecture, we would be able to have, at some point, better energy consumption. Right now, I don't know, but we won't go for a different architecture and large investment in our infrastructure without testing that.
So you could, for argument's sake, spin up some nodes under AIH64 or PPCLE, right, test out your application stack, and then, right, assuming that works, you could buy the hardware, and then you'd have all of your infrastructure set up. You could do your testing first, and then buy the initial set. An actual hardware architecture, hardware hypervisor.
Yeah, that's all planned. Because we already have the cloud that can do that. Yeah.
So another use I can see is for education. Like, I work with an organization in Australia that does defense hardening. They teach people cybersecurity and stuff like that. So they will spin up networks and hosts and public clouds, and then say, go break it. So you could now, instead of having a virtual router, you could actually emulate your Cisco device in there, and then you could break into the Cisco device. You'd have a whole range of really fun exploits you could do.
Yeah, and that's exactly right, and that's exactly what we do. Right? Because if you look at any vendors nowadays, right, gone are the days where it's just, oh, buy this appliance or buy this device. It's, because of the prevalence of cloud, a lot of vendors, they do AWS, Azure. They'll provide, if they don't have an OpenStack cloud, well, if they're on AWS, that means they can run an OpenStack, right? So it's a lot of vendors nowadays are going that route of, they have the virtual images, and that's exactly, that's the prime use case that we do along with the research is, spinning up full Active Directory, Exchange, having a Cisco router, and that's exactly what we use it for. But like I said, we're not a public cloud, right? So we have a lot more flexibility. But yeah, for that use case of doing, that would be, once again, it becomes stage one versus making the big cost sink and then realizing, oh, there's a lot more work that we have to do to configure this.
Yeah. So in the organization I work with, we'll do it for, in the evaluation periods of times, they will spin up, I think the last time they spun up 15,000 VMs, some of which were routers and some of which were Active Directory nodes and similar things. So, and they do that in public cloud. They can't do the actual emulation of the routers and switches and stuff like that, which is a bit of a problem, but with this they could.
Yeah. But I think that's about all the time that we have. I appreciate your guys' participation and coming to see and hear about emulation. As I said, this will be open, so feel free. Once again, the link at the top there. Feel free to add to this. This will be open, and I'll be leveraging this after the summit too to pull back, and you'll see an outcome pop up out of this. But I appreciate it.